Welcome to our latest CodeTalk session, in which members of the Developer Advocates team at Oracle have conversations with developers out in the real world about how they're using our technology and hopefully how you can best use it as well. And our topic this month is JSON in the Oracle database. And joining me is Darryl Hurley with Implestrate, who has been exploring JSON in the database and new features in Oracle Database 12c releases 1 and 2. And I thought it'd be a great opportunity for him to share what he's been learning with all of you. So Darryl, tell us about yourself.
I've been working with Oracle, specifically SQL and PL SQL, for 25 plus years, a little bit more than I care to actually remember. Recently branched out into the JSON world because a lot of developers where I currently were eager to move us to a JSON database. So I figured I'd go in and figure out what the all the fuss was about. So that's why I'm checking out JSON.
Great. And I've known Darryl for a number of years. Obviously, he's been around for a while. He's helped me out with several of my books. He's contributed quizzes to the PL SQL Challenge, now the Oracle Dev Gym. And he's always been great at really diving into some like edgier technologies in the Oracle database sphere. And certainly JSON has become a critical technology for JavaScript developers, most importantly or most narrowly, and then more broadly doing website development. So what we thought would be great for all of you to be aware of is how Oracle Database is keeping up, is providing really nice JSON functionality, both to us who do backend development, but also to JavaScript developers who want to leverage the best database in the world. So tell us about JSON, and then we'll dive into the details of Oracle Database implementation.
So JavaScript object notation is, it stores text in a straight text format for transferring around directly. It has key value pairs denoted with lovely squiggly brackets and semicolons and quotes. And it can also include arrays, very different from what's historically stored in the Oracle database, which is relational data with tables having rows with columns.
Great. So when you're working with JSON, you're going to be working with squiggly brackets. And if you've been working with Java and JavaScript over the years, hopefully that won't be too dismaying. All right. So let's talk about the features available in Oracle Database, starting with 12.1 in JSON.
12.1, the big introduction was the ability to store JSON in the Oracle database, and we'll do a demo of that, and access it via SQL. And SQL can use dot notation, which sometimes can be known as dot over agonizing dot if you get too deep into it. Mm-hmm. And there's also some SQL functions that Oracle added to make it easier to query the data in the table. One important thing to note is that you can't directly update a single element in the JSON. You have to fix entries in the string and then put the whole string back in.
Want to show us some JSON in the database?
I would love to show some demos. All right. So first up, I'm going to create a table, and it's going to look like a create table statement that a lot of Oracle database people will have seen many times, except for the last constraint there. It's actually a check constraint on what I'm calling my JSON column, which is the data type of clob. And it's going to verify that all of the data I attempt to put in there is actually valid JSON.
So there's no JSON data type?
There's no JSON data type, that's correct.
And that's different from the way we supported XML, right? There's an XML type.
That's true. Oh, I already created the table.
We'll take it.
I'm way ahead of myself. So right now, when I run this insert statement, if I attempt to insert these values, and as you can see, the last column I'm inserting is not JSON.
Because it doesn't have squiggly brackets.
Yep, squiggly and square coming up. All right, so I'm going to move ahead one check here. All right. So here's an insert statement that will actually work. I'm inserting values, the values clause, and then here's the JSON with the squiggly brackets to denote the key value pairs, And I even included a JSON array, which is denoted by the square brackets. So for this particular case, the key is name, and the value is Marty. So that's an example of a key value pair. And then my second element is reason, but it's actually an array denoted by the square brackets, and that has medium, title, and year, and it's for 3 separate movies. So after inserting that, and then running this query, there's what we see. It's pretty ugly, pretty hard to parse manually. It is literally just the JSON text that we inserted, not really much value at this point.
And in SQL Developer, can you like click on the column value there, and does it pop up with anything that's more structured than a single line, or is that just the way it is right now?
That's just the way it is now.
Okay.
So the better way to navigate through those values, the first way to do it is using dot notation. So the first entry before the dot is the table alias, which in this case is JD. And then the second entry is the name of the column. And then we search for the actual element within the JSON. So this is going to show us the name element. And note that it is annoyingly case sensitive. For example, this won't work.
Wow, SQL that's case sensitive. Cool.
Yeah.
Now SQL really is modern and cool.
Yes.
Actually, one question before you proceed. If we can go back to the insert statement. So just to kind of validate that check constraint, it certainly didn't think that 1 was valid JSON. If you make a mistake in that syntax, like take a double quote off of around movie, for example, will it fail? Just change something in the string itself?
The quotes it'll still accept because it accepts what's called lax JSON, and that doesn't include the double quotes. But if you made a mistake like leaving out a squiggly bracket or a square bracket, it would indeed fail.
Show us, show us. I'm from Missouri.
Okay, let's say I make this square bracket go away. Try that insert again.
Cool.
Check constraint violated.
No, I just wanted to point out that what's really nice here is with a lot of features in Oracle databases, our developers try to do as much of the heavy lifting for you as possible. So simply by saying check constraint, it does all this work of analyzing and validating it for you. I suppose it'd be nice to have it not only say check constraint violated, but here's where the problem was. But so far, we're not doing that. Okay, thanks.
Maybe Oracle 12.3 maybe.
Or 18C release 1.
18C, okay. So the example I showed previously, I queried the name column, and name was an init cap. Annoyingly, if you don't include the correct capitalization, it won't find the value, but it will still return a row, but the value it returns will be null. So that's different from normal SQL. If you tried to query a column that wasn't there in straight SQL against a relational database, the query wouldn't work at all. In this particular case, it runs perfectly, but because the lowercase name element doesn't actually exist, it simply returns null.
And I know with object types, if you're referencing object type instances inside SQL, you have to have a table alias. Is that true here too? It will not work without an alias? Or you could...
It will not work without an alias.
All right, thank you.
Okay. Now, the next example, I'm going to do dot notation going a little bit deeper into the reason array, and I'm going to specify star within the square brackets. So that's going to return the title key for every single entry in the reason array. And notice it bundles them up as JSON by wrapping square brackets around it and returning it as a JSON array.
Nice.
So that's how it returns array values. Now, if I simply wanted the first entry.
Ah, yes, 0, not 1.
Correct. I've been bitten by that many times. It returns a scalar in this case. So if it's going to return multiple values, it'll return it back to you as a JSON array. If it's a simple scalar, you get the one value back just as a scalar.
So it sounds like one thing to keep in mind as we start to explore this functionality is that kind of once you get inside the JSON, referencing the JSON elements here, you have to use JSON syntax. So for example, the array starts at position 0, not 1, which is how PL/SQL collections work. And the wildcarding is not % or underscore, it's star.
Correct. It's also important to be cognizant of what's going to get returned. If your code is expecting a JSON array and you get back a scalar, you have to know how to behave. So now we'll move on to the actual SQL functions provided in 12.1 for querying JSON data. First up is JSON. Very similar to JSON dot notation, except the syntax is a little bit different. You still have alias dot column name, but after that you specify within the quotes the column you want to see. $ denotes the top of the JSON tree, and then dot name denotes the first element called name underneath it. So when you run this query, you get back the value of Marty. And this is also annoyingly case sensitive. Note that you still get back a row, but simply a null value.
And so if I had 10 rows in the table, this would get me the name value for all the keys across all the rows.
Correct. So now I'm going to do JSON value again, and I'm going to go down to $reason, but I'm only going to return the second title because I'm specifying one.
Right.
So I get Madagascar escaped to Africa, and also notice that this came back as a scalar value.
I was just going to remind folks that you can enter in questions, and here's the question. What data types are the JSON element values? Will Oracle assign number, date, varchar2, etc. data types to what's being returned?
Fabulous question and perfectly timed, because I'm just going to talk about that right now.
Excellent. Thanks, Dan.
So JSON value, you can tell it what data type to return. In this particular example, I'm saying return varchar2 5. You can do varchar2 5, you can do number, and you can do date, timestamps, and 3 or 4 others that I can't remember right now.
But it doesn't have to be varchar2 5, right? It can be varchar2 anything?
Correct.
Okay.
So in this
it's like a real-time casting of the data being returned. So it's a string unless you specify otherwise.
Correct.
And if you specify something else, it'll try to do the explicit conversion and then give you an error if it doesn't work?
That's correct. Another beautifully timed segue. In this one, I'm returning varchar2 4, which won't fit Marty because Marty is 5 characters long. So it's going to return null, which is the default behavior whenever JSON value encounters an error. It simply changes the value to null. The SQL statement does not fail outright. If you want to change that behavior and say, you know what, I want this SQL statement to completely fail if it encounters any sort of error, is to specify the error on error clause for JSON value. So that gets you this behavior. It even tells you why it failed, because the output value is too large.
Nice. Can you change that to returning date? Okay.
So it supplies you with the actual error message when it tried to convert Marty into a date.
And are there options besides error on error?
Error on error, null on error, and a default value on error, which I'm going to show right here.
Uh-huh.
So whenever it encounters an error, it's just going to return ABC instead of null.
Cool.
So whenever it encounters an error, you simply get that string back.
And I've got a few more questions here. Can you return repeating data as a table similar to XML table?
Repeating data would get returned as a JSON array.
Right, as an array. That makes sense. Okay. And anything, just to jump ahead probably from this question, and you don't have to answer it right now as long as you've got it coming up, how easy is it to convert a JSON array into I guess, a collection or something that you can drop into a table? Or treat it as a table for a join or something like that?
We'll cover that when we get to the PL SQL section.
Cool. So that may be what this one's about too. Can you join to another table on a value from within a JSON structure? So I assume that's like doing a join clause.
Yes, you can do that.
Do you have an example?
Not in this set of slides, no.
Okay.
If I'm feeling brave at the end, I might dummy one up.
Sounds good. And the last one I've got here is, can I get the name of columns within a JSON array stored on the table?
You can indeed, and I'll show that in the very last set of SQL where we demonstrate data guide.
Data guide, yes, a really excellent feature. Okay, continue, please.
All right. So I'm going to add a record, another JSON record into this particular table, but notice it doesn't provide a name key. It'll still let me insert it because it's perfectly valid JSON.
Can you just go back to the original? Sorry, just the original one that had the name key in it so we can see the difference again?
Yeah.
So a name, colon, and Marty, right? That's what we're talking about. Okay, so we left that out. Thank you.
No problem. Okay, so now we're going to see how it returns empty values. Empty being not included in the JSON. So it returns it as a null, as expected. And this also is a good place to show you where you can include JSON value in the where clause or anywhere else you can use functions in SQL.
So you can use that as a join condition, same thing.
Yeah. So now I'm going to, when I ran that previous query, that used the null on empty behavior, which is the default behavior. If you want to specify that explicitly, it's like this, specifying null on empty. But if you would wish it to error out when it encounters an empty or missing key, specify error on empty. And it gives you a semi-descriptive error here saying JSON value evaluated to no value. That means it simply could not find the name key.
And I think that default behavior makes sense in that when we keep in mind that one of the main motivators for JSON from JavaScript developers and so on is, I don't want to deal with database design. I don't want to deal with schemas. Let me throw whatever I want into these JSON documents. Each JSON document can have different attributes. So you're not going to blow up. You're just going to yeah, whatever. There's nothing there for you. But if we want to be more strict about the design and about the contents, then we can specify erroring out.
That's correct.
By the way, folks, at some point I'll say something that's not correct, so Darryl will have to say, sorry, Steven, that is not correct. Keep going.
Just let me know when that comes up in case I miss it.
No hints.
Can also specify that a default value be shown if there is indeed no name. So if in your code you didn't want to fail because there wasn't a name value, but you still wanted to know that it wasn't there, you can specify a default value.
Another question. Is it possible to create a function-based index on a JSON field?
Yes. We'll do indexing actually at the end of this demo. We'll show indexing.
Great, thanks.
So that covers dot notation and JSON value. Now we're going to talk about JSON exists, which, as you can tell by the name, it checks if something exists in JSON. So here's the clause right here. It's going to look in the table aliased as JD and then JSON call in that table. and it's going to look for the top level, starting with the $, and it's going to look underneath that for the .name element.
So it's not looking for a specific value. It's asking, is that key in the JSON text?
Correct. So the only entry that has an entry, or sorry, the only entry that has a name element is the one for Marty. The second one that we entered does not have one.
Okay. And just to be clear, or let me ask it this way. So when the where clause specifies the $.name, then that means that the only thing you can select in the select clause is $.name?
Nope, you can go all the way down to any elements within your JSON.
So I was incorrect, okay.
I win. Now, JSON exists can actually be used to find particular values within the key. For instance, this case, I'm going to start and looking at the name element, but I also only want to return where the values are equal to Marty. You can also specify not equal to, you can specify contains, and several other clauses.
Now, is this any different from saying where JSON value equals Marty?
Nope.
Okay.
This gives you this particular example doesn't show the full features of it. Mm-hmm. If you want to do a contains, you can't do that in a JSON value. You can only do it in a JSON exists.
Okay.
Now, here's a brief introduction to indexing. So the first index I'm going to create is using dot notation on the name element. And then the second index I'm going to create is doing JSON value, and it's going to look for that same name element. Now, historically, this would fail in Oracle, and it would say this column was already indexed. But because the first one uses dot notation to find the column, and this one uses JSON value to find the, I keep saying column, I mean element, it allows it as a separate index.
Okay.
Now, if we do an explain plan, using JSON value to find the name element of Marty, then view the output. Sure enough, it used zebra name 2, which is the one that used JSON value.
Nice.
All right. We'll move on to.
Have you done any testing around performance of, for example, these different indexing? And
not with the big enough data set to show any huge differences, unfortunately. All right, I'm going to bring up the next demo script. All right, now we're going to move through the two last functions allowed to do SQL against JSON. First up is JSON Query. JSON Query is a little bit quirky in that it can only return JSON. It will never let you return a scalar. Here's the syntax right here. I'm going to start at the $, which denotes the whole JSON text should be returned. And here's, of course, the call to JSON Query. Doing that, do my database connection, and it returns the whole JSON text. Fully built in the squiggly brackets and the square brackets and the quotes, just as we inserted it.
Yeah, here's a question. Could I convert that? You can probably try it out right away, if you don't know the answer. Could I, instead of referencing JSON call inside the call to JSON query, can I have a select statement, select JSON call from JSON data? Is it or a thought?
That I don't know.
Give it a try.
You're so brave when you're not doing the typing.
Oh, it's not going to be your fault. I'm just curious as to how thoroughly they've extended the functionality. Obviously, in a lot of places, I'm sure people know now, you can do single value selects all over the place in place of values, in place of expressions.
I assume you mean this.
Exactly.
And the answer is nope.
Now, one more thing, put them inside parentheses, the select statement. But I'm pretty sure the answer is no right now, yeah.
Like this?
Yeah. Thanks.
Still no.
Oh, no, that's different. It worked. It's just not a single value.
Okay.
So I won't take more time with more of your typing unprepared, but it looks like you can do that. We just need a where clause that says just get Marty or just get whatever. Okay.
Or good old where row num equals 1, that'll work too.
Yeah, okay. No, it has to be inside the subselect. That's the failure point.
Good point.
See, folks, I've got him addicted to trying things out now in his session. I wasn't even asking him to do this.
Now the presentation is going to be 12 hours long.
Beautiful.
There you go.
Beautiful. Excellent. Nice work, SQL team. And I do have a question. Can you use JSON query to select from a non-JSON column?
JSON query can operate on any column that contains JSON data.
Okay.
That particular column does not have to explicitly have the check constraint on it to make sure it is JSON.
Excellent question. Great. And I think that's probably the advantage of also not having a special data type for JSON data. It's just text.
Yep.
So use wherever. Excellent.
All right, now JSON query.
Sorry.
We'll run it again.
The question, somebody just had a question from the very last query. Why did it return 2 rows? And the reason it returned rows is that we were doing a from JSON data with no where clause. The only where clause was applied inside the subselect. So if there was a where clause on the select from JSON data, the outer query, then it would have just returned 1 row.
Yeah, that's true.
And the reason it returned the same value both times is that we were selecting where row num equals 1. There was no specification of order or specific row.
Yeah, so it was only the row with Marty.
Okay, thank you.
All right, now we're going to do JSON query, but we're going to specify we only want the name element. And this will fail outright because JSON query cannot return scalars. It desperately wants to return JSON. But the error message is interesting in that it says it can't be returned without a wrapper. So JSON query desperately wants to return JSON, but it wants to make it easy for you to do that. So you simply specify with wrapper. And note that the second row came back as no because $name doesn't exist in that particular record.
And now it's an array with just a single element.
Correct. And again, that's important to note because if you're writing code, you have to know that you're going to get back an array, even though there's only a single element.
So here's a big question, which you can take now or you might want to wait till the end. Why would we want to store JSON in a relational database instead of in a NoSQL database like MongoDB, which actually isn't a NoSQL database, it's a document database?
That's a big question, so we'll chat about that at the end.
Okay. We'll get back to Orlando.
JSON query, similar to JSON value, you can also specify what the error behavior, what the error behavior should be. So in this particular case, I'm going to return $name, which is a scalar, but it won't let me because it doesn't have a wrapper. However, instead of failing, I'm just going to return an empty set or an empty array. So that's the empty on error behavior. Last but not least for the JSON query functions is the JSON table function. It's very aptly named because it turns JSON data into a table with rows and columns, which the old-fashioned relational developers like myself really enjoy. A little bit weird in that you actually do a query from the table, which in our case is JSON data, and then right underneath it you specify the JSON table clause on how to modify that data for display. So it's JSON table, working on the JSON column within that JSON table, starting at the top level, going to reason, and displaying all of the elements as denoted by star. Now it's going to turn that JSON data, the keys and elements, into columns and rows, so you have to tell it what the columns should be. So the first column I'm going to call type, and I want it to take the medium element from the JSON, display that in that column, and I want the title element from the JSON to be displayed as title, and I do the same for year. So it's going to translate every entry in the reason array in JSON into a table display with columns and rows. So there's the return values from that.
This is odd syntax. So the reference to JSON call inside JSON table is referring to a column in the JSON data table.
Yep. When I first saw this syntax, I expected to have to specify a where clause to join the two.
Yeah.
So you're right, it is kind of weird syntax.
And if I had multiple tables in the from clause that all had a JSON call column in them, then I could qualify them with the alias name or something like that. Have you seen anything about
Yes. You could qualify them with the aliasing, but there's a known bug. When it tries to join between the two, it doesn't work so well. You wind up getting all the rows back.
All right. Well, that'll take some getting used to for sure.
Yeah.
If I had the product manager on the call too, I'm sure he would explain why they did it that way, but unless you know, I sure don't know.
All right. And a feature within the JSON table call is you can actually do nested paths. So for this one, my leftmost column is going to be called NM, and I'm going to include the name element from the JSON there. But then I want to go further down within the reason array associated with that name and display that data as these columns. So I'm basically decompressing, I guess is probably the word, the array elements and showing them up with their parent being the zebra name. Note that you can also include an ordinality column to keep track of where you are within the data. In this small data set, it doesn't really make much sense, but if you have a big data set, it can be pretty helpful. So we run that query, and it shows the name and the movie as a single row in a table with the column.
Nice. And I've got a few questions here. It's hard in this UI to notice when new ones come in. Apologies, everybody. So one question is there an omit row on error option? I guess if it errors out, just skip it. Don't have it show in the results set at all.
No.
And I've got a question. In this case, what happens if reason is missing in one of the rows, but I don't know what in this case is? My apologies, Arlo. If you want to clarify that, I'll pick it up right away.
I think what he means is if there was JSON that didn't have a reason element, what would happen?
Mm-hmm. Yes.
I don't feel brave enough to dummy up one now, but I will definitely check that out later and tweet about it.
Okay. And we'll be offering Darryl's Twitter handle and other contact information at the end. So stick around. And you were right. That's what Arlo was asking about. Okay.
Okay, good.
We're moving on to 12.2.
Now we're on to 12.2, yes.
Wait, it's my turn to show the slide. I'm going to be the presenter if I can change it. Okay, so JSON and Oracle database. So you showed us 12.1, but in 12.2, which I'm sure everybody's got installed, you can access it live SQL or get the Exadata Express service, the cloud service. We've added a number of different features, both in SQL and more importantly for someone like myself, in PL SQL. Take it away, Darryl.
All right. Starting out with 12.2, Oracle introduced JSON Object AG and Array AG. What that does is it aggregates entries out of a table, columns and rows, and aggregates them into JSON arrays or JSON objects as you see fit.
Okay.
It also introduced JSON functionality into PL SQL. Introduced objects, JSON object T, JSON array T, JSON element T, and JSON key list. And it also introduced, and this is how we know JSON has truly hit the big time, JSON has its own DBMS JSON package in Oracle now.
Right.
And last but not least, Data Guide is introduced, which allows you to get a guide to what's actually in your JSON data and even see how frequently certain elements occur.
And that one really caught my eye because I know that a lot of people who are have a relational database background are just amazed that developers would want to be able to throw whatever junk they have into these JSON containers, and each one could have a different structure. How do you know where there are gaps and inconsistencies? And it seems like Data Guide is a really great piece of added value from Oracle SQL around JSON support.
Yep, I agree, and it's sometimes referred to as a JSON schema is what that definition is.
But we shouldn't say that because that'll just scare people away.
I agree. That's why I just want to brush past it. All right. So the first thing I'm going to do here is I'm going to revisit that data that we just did in that previous query. So it's got the name of the zebra and all of its movies, including the one that doesn't have a name. So what I'm going to do is I'm going to create a table called demo that will have all that data. So I have now officially taken all of that JSON data that was stored in a JSON column in a table and created an old-fashioned columnar table.
So there's no JSON in this thing at all?
That's correct. So now the first thing I'm going to show you is JSON Object, and that's going to operate on the title column in that table and the year column. And it's going to display that as a JSON object with the title values as the key and the year values as the value.
Okay.
And it even wraps it in the lovely squiggly brackets for you.
But it's just a string. It's not an actual object type or anything like that. It's a string.
Correct. It's just a string that you could then parse inside your JSON handler. And note that you get one row return for every single row in the table.
So just to be clear, what we're really talking about here now is, so in 12.1 we put in this basic JSON support. And then in 12.2 now what we're doing is making it easy to take that relational data and surface it up as JSON for a JavaScript developer and so on to be able to leverage, even if the data itself is not stored as JSON.
That's correct. Now, similarly, the JSON object AG for aggregate, is going to operate on those same two columns, title and year. But the return value is going to be different. You're going to get all of the values back as a single JSON entry.
Not an array.
Correct.
That's coming up. Okay, I get it.
Yeah, it's in the squiggly brackets, so that's not an array. But it's returned as one single value, not one value per row.
So it's kind of like list ag, where you take.
Yes.
which is probably why they named it that way.
What came first though, object ag or list ag?
List ag for sure.
Next up is JSON Array, and that in this case we're going to operate on the year column. That's going to display one array element per row, and it's going to show you just the year value. So this is an array, not an object. Each array has a single element, so it's not really a very useful array. To make it more useful, you'd want to use the counterpart JSON Array ag. So that's a little more befitting the array, but actually having multiple entries in it.
By the way, we just had another question from Orlando. It seems that querying JSON using SQL language is harder than using NoSQL query commands, isn't it? Well, I don't know because I don't know NoSQL query commands.
Yeah, I can't answer that either.
I've got to say though, Orlando, that's probably somewhat dependent on what you're most used to. Certainly, many NoSQL databases and document database technologies have been layering SQL on top of those databases because they have found that it's really hard when you don't have a language like SQL. So I imagine to some extent it's just what you're used to, but in general the industry has moved away from SQL, or at least some of the newer technologies, and those same technologies have moved back to even the explicit, not only SQL, NoSQL databases.
Yeah, I know for example Couchbase now has SQL, and it actually looks quite similar to Oracle SQL, of course, because it's an industry standard SQL.
But they call it NewSQL.
Yes.
All right.
Excuse me. Next up is JSON Object. What that is going to do is it's going to create a JSON object wrapped in nice squiggly brackets with these values, medium, title, and year as the keys, and the values from the table, the columns MDM, TTL, and year as the values. So it's going to generate key value pairs for those. And notice you get one per row that's in the table.
Mm-hmm. Nice. We had one question. Looks like the output is not in the name value pair format. Can you get the name value notation? And that's just what you showed us here.
Correct.
So it seems like the value constructor does give you name value pairs.
Yeah. Now, this is just another entry or example explicitly specifying format JSON for JSON object. And that is actually the default behavior, but I'm just showing it for the sake of demo.
And here's a question. Can the value be a nested query to generate a nested array? Can you put a select statement where you've got like MDM or TTL or year?
Based on what we just did prior to this, for a similar question, I cannot see why not, but I'm not brave enough to try it now.
Yeah, definitely something to explore. Okay. Stuart, please explore that and get back to us. And by the way, we're at 12:46. So
wow.
Yeah, that's what happens when you got me asking a lot of questions.
Yeah, it's always your fault.
You
can also nest objects. In this particular case, I'm going to have one single JSON object for the zebra name, and within that, I'm going to have a JSON object showing the reasons. So the outermost object is zebra name, and reason shows up here as another JSON object within that JSON object. So that shows the nesting.
And a few more questions. Is there a size limit on JSON object ag?
No.
I think it returns a clob.
Yeah.
Okay. So there is a limit, but you're not going to hit it. Do the key values have to be hard-coded so that the string like medium and single quotes to the right, to the left of value, does it have to be hard-coded? Can that be, for example, a column name?
I believe it has to be hard-coded.
Here, go to line 48 and just replace zebra name with NM and see what happens. I think what we'll have to do is organize another code talk just on the PL SQL features.
Yeah.
No. Okay.
All right, so moving right along.
In 12.1, storing JSON in cloud fields, it was recommended to use UTF-8. Are there similar character set restrictions or recommendations for 12.2? I don't know of any changes in that regard.
No, I believe it's still the same. You'd want to go UTF-8 or UCS32 or whatever the next one up is. I can't remember off the top of my head. And if you're really worried about character conversions occurring along the way, you can store your JSON in blob fields as well.
Now, it's 12:50. I have a suggestion. Show us data guide first. And if we run out of time, we'll let the PL SQL stuff go.
Oh. All right, data guide. So what data guide does is it examines your JSON data and gives you essentially a guide to what is contained within it. But in order to keep track of what's in your data, it needs a special index, which is a JSON search index, which I'm going to create with this statement here. And it's going to take a little while. Parse that JSON. I'm going to create that index. So next up, I'm going to create what's called a data guide. So the first thing I need to do is call the DBMS JSON guide and tell it what sort of information I want in my data guide. Tell it what table to use, what column to use, what format, and whether to make it pretty JSON or not. And I'm going to output that so we can see the value. And the handiest thing is it can actually create a view based on that data guide. So we'll run this. And we'll go over to our DBMS output. And here's what it puts out for the data guide.
So it's got JSON output about your JSON.
Yep. It displays the data type and the length and preferred column name, which is assigned by Oracle. And then if we go over into our views, see that it also created a view with those values. So we could use that view for querying, knowing that we got everything that we specified in the data guide. So there's what that particular view would return. And again, realize this is working on top of the JSON data table, which actually contains the JSON columns. Skip over that query in the interest of time. You can also create a view without going through the data guide portion using DBMS JSON create view on path. We'll refresh our views. And interestingly enough, you'll note that even though I asked it to only work on reason.title, it still included the primary key column and the name. That's probably a bug. So if I select from that particular table, there's the entries it has. Now, I mentioned you can specifically include elements that occur in your data a certain number of times. That's called the frequency. In order to calculate that, you have to use DBMS stats and gather stats on the particular search index. So we'll run that, and we'll quickly go back up here and generate our data guide again. When we look at the output, I didn't clear it. And when we look at the output, it's going to tell us the frequency of the particular columns and the low value and high value, just as it would if it created on your index, if it created a whatever the word is, I can't remember now.
That's.
I'll think of it later.
Let's see, if the original JSON has a new attribute or record added after the data guide has been run, would you expect the view to fail? So you created the data guide, then you've modified, added additional attributes into JSON documents.
No, it would still succeed. And
just pretty much what you'd expect for JSON functionality.
Yeah, and the reason I know that is because the view, the text used to create the reasons view, it actually contains all of the JSON calls, and it actually makes a call to JSON table. So even if you added new columns, the view would still work.
And another question is, not surprisingly, can we have the sample code in the slides used on this presentation?
Definitely. I'll upload it to my site later today.
To your blog site?
Yeah.
And the link's coming up for that. Okay.
And so another reason to calculate your frequency is you can use that to restrict the actual columns that will get included when you create the view. So previously when I ran this create view on path, I got every single column, even though I only asked for reason.title. That's probably a bug. But a good way to completely exclude columns is to specify you only want ones with a certain frequency. In this case, it's a frequency of 100. So I only want it to include these particular elements if it occurs in 100% of the rows.
Your common attributes, nice. And the word that Renee thinks you were looking for was histogram.
There you go. Thank you, Renee. So now you only get name, and, oh, all right, and reasons too. You only get the column title, which is what we actually asked for.
Nice.
And if you want to query the data guide as is, straight out of your database, you can simply use the JSON data guide function, and that gives it back to you as a string. Be aware that it returns the data guide per row, because it assumes that it can be different.
And I suppose you can do a distinct on those and find all your distinct variations on attributes and so on.
Yep. You can also, and I won't fully do this demo because I know we're short on time, if you want to change the names for particular columns, like in this example, you wanted the name element to have a name of zebra name in the view, you can run this. And similarly, you can change the name of this particular element. And that, in a nutshell, is data guide.
Nice. All right, so we're at 12:50. Sorry, go ahead.
And that concludes the demo portion of this presentation.
All right, so I think what we'll do is hold off on trying to jam in the object type additions for PL SQL in 12.2, and I'm going to look at scheduling another session with you because there's a lot of JSON stuff to explore.
Agreed.
Let's talk a little bit about some of the questions that Orlando was raising, and certainly, folks, if you have other questions, feel free to type them in now. So Orlando would raise the question of why would you do this? You've got MongoDB, you've got document database that are like JSON native databases. Why would you ever think about using JSON in an Oracle database? Hopefully, I put the right incredulity into that question mark.
The right emphasis. If you put it into Oracle, of course, you get the industry standard backup and recovery. You get the transaction control. You get the features. We have sharding in Oracle 12.2. You get features like that. The indexing features that Oracle has, I know they're different from what NoSQL has. Be careful to note, I did not say they were better. I just said they are different. So really, it's just the overall features of the Oracle database that I mentioned that you would gain. A particular JSON functionality, it's probably going to be the same, maybe a little bit better here and there.
And just another point, another perspective on that is, I think that the idea of adding JSON support to Oracle database was not to say to those guys who are doing native Mongo database development, like JavaScript, 100% up and down the stack, hey, don't use Mongo, use us. Though we'll say that, and we'd love for you to do it. I think right now our main focus is we've got Oracle database installed all over the place. And one of the members of my team, Connor McDonald, told me about the company that he worked for before he came into Oracle a few years ago. They had Oracle database all over the place. They just upgraded to 12c before he left. And he was talking to some of the developers, and they're like, yeah, you know, we started up a new project. We need to work with JSON. So we're talking to our managers about installing MongoDB. It's like, you don't have to do that. So if you've got Oracle database installed, and you're building out new apps and you need to work with native JSON data, the main thing I think to take away from this call and from 12.2 and Oracle and JSON support is you don't have to install a document database. You don't have to stop using Oracle database. You can still do everything you want to do with JSON inside Oracle database. So you can look at it both ways. Should you never use MongoDB and only use Oracle? Well, I work for Oracle. Yeah. But we understand that there's going to be a polyglot of database technologies. But if you've got Oracle database in place, we're providing you with pretty much every option around data support and data type support that we can.
Well said.
Thank you. All right, let's see, more questions. Because you already have a live database in JSON as a useful medium to add an extension to it, just what I was kind of talking about. XMLDB has a repository for files that can be actioned via SQL, PL/SQL, etc. Files can be created here via PL/SQL. Is there anything like this for the JSON support in Oracle 12c?
What sort of files? I'm wondering.
Yeah, unfortunately, I'm not strong on XMLDB to understand what you mean by a repository of files. So Michael, if you want to clarify, go ahead. Stevens also added that using JSON in the database is an easy enabler for web services. And certainly, that's a great point, Stuart. So when you think about REST APIs, they're almost always going to be involved transferring JSON in and out of the database or in and out through the REST API. And so the Oracle REST data services, our REST tool that can auto-enable tables and even PL/SQL APIs now, can very natively work with this JSON data. So having the JSON in the database is a natural nice flow. Here's another point. I've been extracting JSON for years using XSLT, but this is simpler. Not sure I'd want to store the data that way, and you get your choice, right? You can store things in relational format, pull them out as JSON, absolutely. Obviously, the other key advantage of having JSON in Oracle database is the reason that we use JSON for very flexible structures that change a lot, and you can have 16 different structures in 16 different rows. So if you have that kind of use case, and you don't want to have to install a MongoDB or something like that, you store it as a JSON document. So Michael follows up, XML files can be created and read in a separate file location on the database server. So Michael, I'm pretty sure that's not a part of the JSON implementation right now. I don't know if they're thinking about adding it, but we're just talking about a CLOB. It's a CLOB in the database, and it just happens to have JSON data in it, and we built a lot of intelligence around managing that JSON data.
You could set up the CLOB file as an external table and then do JSON on top of it.
Okay.
Because the actual, as I said, the actual column does not have to necessarily have the constraint on it saying it is JSON. It could be a column that refers to an external table, which is a file out on the file system, and you can do your JSON queries on top of that.
And I imagine even with the external table, you could specify that column as with a JSON constraint, perhaps, when you construct the control file for the external table. I haven't explored that deeply enough to know.
Yeah, you might be able to.
If not yet, maybe soon. All right, it's 2 minutes after 1. I think we've gone through all the questions and comments. Darryl, thank you so much. That was really, really interesting. Just in case you folks haven't picked up on it, I'm new to JSON in the database, and I'll be, in fact, gearing up for that into the next year when I start publishing some Oracle Magazine articles. So look for my take on Darryl's contributions, and I'll be looking at his sample code as well. So go to impulstrat.com, check out his latest blog post, so you'll post the slides and links to the content as well, right?
Yeah.
And feel free to use Live SQL to store all that stuff. Follow Darryl at ImpleStrat so you can keep up to date on JSON in the database and all the other stuff he's working on. And why don't you talk a little bit about what you've been doing with O'Reilly?
A year and a half ago, I did learning Oracle PL SQL videos. That was quite exciting to get to do that. And earlier this year, I did Oracle SQL JSON videos, and that was the features that were introduced in 12.1. I'm considering doing videos for the functionality introduced in 12.2, but I hope to drum up a whole bunch more interest first.
So everybody, go to Safari, especially if you already have membership. For example, at Oracle, we all have membership in O'Reilly Safari. And go check out his videos and content around PL SQL and JSON to encourage him to do more of that stuff. And what's that last line on this page? Quizzes at the Dev Gym. What's that? So go to devgym.oracle.com to take quizzes and workouts and classes on SQL and PL SQL and other Oracle database functionality. And Darryl has written a number of quizzes for us over the years. And I think we'll be seeing a lot more in JSON going forward in 2018. All right. Thank you very much, Darryl. That was a lot of fun, very enjoyable. I learned a lot, and I'm sure everybody else did too. And I'm going to bring you back in 2018 for another session.